So in the next lecture, we're going to talk about minimization and maximization. Right. Making functions as big as possible or as small as possible. So how does it work in one variable? So in one variable, right, we have a curve. To find the smallest and largest values of this curve, we find the critical points. Right, the places where the tangent line is horizontal. Or undefined, right? If we don't have a tangent line, then that's also a critical point, but we'll focus on that for now. Then, once we've got those critical points, we analyze whether they're maxes or whether they're mins. One way to do that is the second derivative test. Right? The second derivative is positive, then we're a min. If it's less than 0, then we're a max. Okay, so is this a familiar story to most people? There's like 3 people who've heard this before. Okay, who hasn't heard of this? Okay, there's one person who has, that's good to know. Okay, so we need second derivatives to do this kind of an analysis. So now let's generalize these ideas to multivariable context, and we'll see what that would look like there. Okay, so our first thing is we need a notion of critical points. Okay, so that's issue 1. Okay, well, we've got a pretty reasonable thing here. We've got first derivatives, right? So instead of saying the derivative in x is 0, let's say the derivative in x is 0, the derivative in y is 0, etc. So So we'll say that something is a critical point. Okay. If all of the partial derivatives at that point are 0. Okay? This condition is equivalent to the gradient at that point being 0. Okay? And if your gradient is the 0 vector, then in any direction that you travel, you won't increase, right? If your gradient is 0, then any directional derivative will also be 0. So that corresponds in a very strong sense to having a horizontal tangent line. Right? If your gradient is 0, you have a horizontal tangent plane. Okay? There's also the case to consider when we're doing maximization that, or one of these things is not defined. We have some directional derivative that's not defined, then we'd be like sort of like an absolute value function. Okay, so we've got a notion of critical point. The second thing that we need to do minimization and maximization is a notion of second derivatives. So we've seen that we can have many, many second derivatives, yeah? If we've got n variables, then we've got like n squared second derivatives. We've got many, many second derivatives. So what we're going to do is we're going to collect all of those n squared pieces of information together into one thing that encodes the second derivative. And that thing is called a Hessian matrix. Okay, so H of F is going to be our sort of our stand-in for the second derivative. And it's going to have as its entries the ijth derivatives. Okay, so we take the derivative in j, and we take the derivative in I. We do that in all possible ways. Okay, so this will collect all the information about second derivatives of f.